All right, so we're going to look at rational expressions. Okay. Rational expressions means fractions with variables, traditionally x, in them. So you'll usually have x's in both top and bottom, which means we have a lot of interesting things to deal with them. The first technique we're going to learn is the simplification technique, which will essentially be the always do this anytime you can and as often as you can. So, to simplify a rational expression, you will factor everything completely and cancel factors from the top and bottom that they have in common. Okay. Things can only be canceled if they are factors, meaning multiplied by everything else. And in fact, this leads us to our second warning, which is, again, an issue with plus and minus signs. So for instance, if I have something like this, where I have an a both in top and bottom, but the one on top has a plus attached to it, nothing you can do can simplify this. I cannot cancel these a's. Okay. I can only cancel a's when they are both multiplied by the other things. So in this case, I could have canceled them. But when they have a plus attached to them, there is nothing I can do to cancel them. All right, so our example of simplification will be to look at this problem. So the first thing we have to do is, again, factor and cancel. Okay, so this is one of the reasons, of course, that we were stressing so much about factoring in the previous video. So on top, it factors as x plus 5, x minus 2. On bottom, it factors as x minus 2, 2x plus 1. Okay, I'm not showing all of the work of those again, but we have reviewed how to do them. I notice that both top and bottom have an x minus 2 factor, so it can cancel, and I'm left with x plus 5 over 2x plus 1. Okay. Next, we will multiply rational expressions. So, the deal with multiplication, I still have to do simplification steps, meaning I'm still going to factor and cancel as much as I can. When I am multiplying, I essentially just squish all the factors on the top and squish all the factors on the bottom together. So, the x plus 2 and the x minus 3 from the first fraction will get multiplied by the ones from the second once I factor it, which is another x plus 2 and an x minus 2, as well as an x plus 2, x minus 1. All right. So really, what I was doing in this step was factoring, and I just no longer wrote it as two fractions and just squished it all together in one. Now, one of the x plus 2's from top and bottom cancel, not both, of course. Okay, and what am I left with is this. Please notice I will not multiply things backed out. You should always return these answers fully factored. Okay. Next, we have division, which is essentially a multiplication problem because we're going to employ keep, change, flip. Okay. Because no one in their right mind wants to divide fractions. So I see a division problem and I will immediately keep the first one the same, change it to multiplication, and flip the second fraction. In other words, I am, instead of dividing, multiplying by a reciprocal. All right, the first fraction, I can pull out a 3 on top and a 2 on bottom. And then I see what I can cancel. I can cancel an x plus 4 from top and one of them from bottom, an x minus 4 from bottom and one of them from top. So what I'm left with is 3 times x minus 4 over 2 times x plus 4. Okay. Now, as seems to be the theme in a lot of things recently, addition and subtraction are problematic, and multiplication and division were much easier. So these are fractions. In order to add and subtract fractions, you have to have a common denominator. So first, factor everything. That's always your first step. Second, we will force a common denominator, and then we'll add. Now, a warning with these. This is the only operation with rational expressions where we ever FOIL. And we only FOIL the numerator, never the denominator. Remember, we keep on saying factor, factor, factor. FOILing undoes a factor. The only reason I'm going to be doing it in the numerator here is because I have to. So, here is my problem. Okay. The first thing I'm going to do is factor everything in sight, which really is just the denominator of that second term. It is a difference of squares. All right, now I need to force a common denominator. In my denominators, I see x minus 2's and I see x plus 2's, so every fraction needs both of them now. So my first fraction needs the x plus 2 on both top and bottom. Notice I put parentheses around all factors. My third fraction needs the x minus 2 on top and bottom. And my middle fraction already has them both, so can be left alone. So now they have a common denominator of x plus 2x minus 2, which will be left alone until possibly the very last step. On top, I have a much more complicated situation. And it is because of these still plus and minuses in the middle that I'm going to have to FOIL everything. So what do I get? X squared plus 3x plus 2 plus x minus 6 minus, and I'm still putting in parentheses so that I can FOIL this step and then worry about the negative sign, x squared minus x minus 2. Okay. All right. Next, I will combine like terms. So I notice actually that my x squared's conveniently canceled because of the minus sign outside the parentheses. X's, I have 3x plus x plus x. Okay. Oh, I see what I did. So 3, 4, 5x. Okay. For my constant terms, I have 2 minus 6 plus 2. So minus 6. And this is my final answer. Okay. And I cannot factor the top further. Therefore, I cannot cancel anything from top and bottom. And this is where I leave it. Okay. All right. There is one other thing I want to talk about with rational expressions, and that is simplifying what I call complex expressions. That is expressions where I have fractions within fractions. Now, these are absolutely horrible, okay? And there are multiple ways to work with them, but I'm a big fan of the way that gets rid of the annoyances as quick as humanly possible. So my trick is to multiply top and bottom of the big fraction, meaning basically the one with the biggest fraction bar, by the common denominator of the little fractions. So my little fractions, I have two of them, 2 over x and 4 over x squared. Their common denominator is x squared. So I will multiply top and bottom of the big fraction by x squared. It will distribute across the plus on the top and the minus on the bottom. So what do I get? 1 times x squared is x squared, plus, then I have 2 over x times x squared. One of those x's cancel, and I'm just left with 2x. On bottom, 1 times x squared is x squared, minus 4 over x squared times x squared. The x squareds cancel. I'm left with 4. And this is immediately much nicer. I do what I always do, which is factor as much as humanly possible, cancel any terms uncommon on top and bottom, and end up with my answer.